Welcome, everyone, and thanks for being here. And we all are here because we want to build solutions, solutions which are solving the real problem, making the world a better place. But before we build the solution, we have to understand the tools and technologies. And to use tools and technology effectively, we must understand a couple of design patterns. And when I say design patterns, by that I mean we are standing on the shoulders of giants. These design patterns are time-tested. Many applications were built on top of them. And so let's look at our first design pattern, which is event notification. So let's see why we need this event notification and what are the benefits of event notification. So if we see the simple application where I have a couple of modules receiving orders and then updating the shipping module and updating the inventory. Now, this application will work fine if I am receiving a couple of orders in a day. And this will work fine also if I am receiving maybe 100 of orders in a day. But this application will start having problem if I receive thousands of orders per minute or hundreds and thousands of orders per second. You can quickly see this application will not scale. The first problem we see here, because when I receive the order, I go all the way down updating the inventory, I will be burning a lot of time to go and call all these modules and come back and send the acknowledgement. And because of this, we will not be able to scale the throughput which we need in today's application, in the modern application, where we need thousands and thousands of events per second. The second problem we see here is tight coupling. If there's a problem in shipping module or in the inventory module, suddenly your application is not working. And order has nothing to do with shipping because order is just supposed to receive orders. And there was a problem in shipping which you can fix it because once you receive the order, you ship after a day or two. But now suddenly your application is broken because of this tight coupling. So what is the solution? So first thing is that we should decouple orders from shipping. Orders need not know anything about shipping. And what we can do is we can throw a queue and we can write an event for the queue that I received an order. Now, a couple of things happen just with this small change. Because I'm not doing any great processing, I'm not doing too much checking whether I have inventory or not. I'm just receiving the call, taking it, whatever the information is there, creating an event, and just writing it on the queue. And I may be back within less than a millisecond. Less than a millisecond or maybe 1 millisecond, I can be back. And suddenly you will see my application is very performant because I'm not doing much processing here. And second thing we see is my system is more resilient. It's more stable. Even if there's a problem in shipping or in inventory module, my system will still keep working. So that's one benefit we see out of event notification. Now, if you see closely, there's another problem there. Can you guess what is the problem there? The problem here is if I am writing an event just saying I received an order, then the shipping module will go and DDoS the order module saying, give me more information, what order, who is the customer, and what are the items supposed to be shipped. So we have to have more context around this event. So that is very important to know when you are building an event notification system. The event should have as much as context it has. Otherwise, the other system who are receiving the notification, they'll go back asking for the more information and context, and that will be a DDoS again on the system. So that's the event notification. Now, our second pattern is event sourcing. So I have an application which is updating my customer data. And again, it's doing the whole CRUD operation, create, delete, update customer. And again, so whenever I talk about application, I think you all build application which is having a global scale and will have millions of users and millions of hit throughput you require per second. So here in this model also, you can see if I'm doing a CRUD and my customer is going all the way, my customer module is going all the way till the database, and I have millions of customers, find out that customer, bring it back, update it, save it back. Again, suddenly I will see that I have a very slow performance of my system because it's fetching the data from database and saving and going through multiple layers. So you can see my responsiveness is hurting, and this will limit my scalability. And if I don't write very specifically code to audit all this, that how many hits I am getting, who is updating the customer, what field is updated, I get my audit history is lost. I have to write a special code to keep all this audit history there. So that's one of the problem here. And second is, there can be update conflicts can happen, especially when I have millions of users trying to update my customer data. And that's why, in our relational databases, we have all different kind of locks, and lock contention happens, and then we fine-tune the query and have a clustered index, non-clustered index, and all those things we have to do. Because our systems were written in this manner, where we go and try to update things online at that moment itself. So what is the solution of this problem? And the solution is the event sourcing pattern. And what is event sourcing pattern is, we take each event and start writing it in a log. It's an append-only log. And I come back again within a millisecond or so, because this is append-only log. My file pointer is already at the end of the file. I receive the event, and I just write it, and I go back. So now, once I have this log already written, I can have a service which can take its sweet time to update my domain, customer domain. But again, as you can see here, that I decouple my application. It doesn't have a dependency on that customer module. It's just writing on the log, and all your customers are having this experience of extremely fast application, because your application can come back so fast. And on top of that, then I can write another function which can read this log and update the customer. So first benefit we see is the decoupling here again. And we already seen whenever we decouple, our throughput improves, our resiliency improves, and our system becomes more robust. Second is materialized view. So what I mean here by materialized view, imagine you have IoT devices, and they are sending their data about temperature, pressure, like 50 data points every second. But as a system, you are interested only in average for every minute. But you want to act on every second data point. And you have defined the low boundary and the high boundary, that if my temperature goes above this, I have to act and do something. But if my temperature remains in that boundary, I don't want to do anything. I just want to put everything together, take an average for a minute, and save that. So that's what I mean by materialized view. Now, with this pattern, you can create a materialized view. So you don't have to save every second of the data. And if your IoT device is sending, I see in system where is hundreds, like 500 data points are coming off IoT devices, and thousands of IoT devices are sending every second data. So this will be a huge, huge thing there when I am averaging everything and putting the data every minute. So that's what is materialized view. Second, because of this pattern, I can integrate with other systems. I can have a system which is quickly sending a thank you note as soon as I receive the order. And that system has to have no dependency on anything, because he's just saying, OK, I got the order, and I'm going to send you a thank you note. So you can have third-party services which can read and send this thank you note. Auditing. Now I don't have to write any special code to audit my whole system, because we are often want to keep the whole audit history. We are interested in on the current state of the system, but often we want to know how did we reach there to this current state. And that's what we can get out of this log, because it's already there for me. I can just save it, and I have the whole audit history. Debugging, same thing. Because I have all the state, how did I reach to my present state? I can look at what is the problem. Is there a bug? Because you can go back in the log, go back in the time, and see how your system was behaving. So this pattern will help you in debugging also. Teleporting. I can take all this log and run it in some other region. And that's how we do the data replication in our databases. We take the log and just run it on the database again. So we can teleport this domain, the customer state, anywhere else. So these are the few benefits of event sourcing pattern. Now I have just one service reading this logs. I can very well have multiple services reading this log. And that's how I can enable my microservice architecture on this. So the benefit of microservices, same thing. Again, I have a decoupled system. All the services are also decoupled from each other. And that, again, brings a lot of resiliency. It's very easy to update because I have each microservice is solving my one business problem. My code is small. I can look at it, understand what's happening. It's no more big monolith code. You guys must have seen a lot of stored procedure written in thousands of lines. It's so daunting to even touch any line here. But now here in microservices, we take one problem and just solve that problem. And that helps to easily update if I have to change anything. Software versioning. We keep releasing the new frameworks and new different versions. And you don't want to take the newest version of .NET or .NET Core and just change to the whole system. If you have this microservice architecture, you can take one service, put the new version, run it, and see how it behaves. And then you can keep rolling to different microservices. So that's another beauty of this microservice architecture, that you can have this software versioning on them. Fault tolerant. Now, because these services are doing separate things, my system is more fault tolerant even if one of my services is broken. For example, in my application, the use case is 95% of people go on, and just read the comments. Only 5% people write the comment. Most of people are just reading. So suppose my write comment service is broken. My 95% of customers are still happy because that's what they are doing. They're just reading the comment, and it's all available there. So your system becomes much more fault tolerant. Debugging, I already talked about that. Because these are very small services, the code is simple to understand. It will help you in debugging very, very fast. And obviously, it's increasing the stability also, because you are not having a big monolith system. If system goes down, few services here and there goes down, but overall, the system still remains stable, and people can keep using it. Now I want to zoom in only on event sourcing patterns and remove all this detail from it. So in a very, very simple form, what is event sourcing? This is event sourcing. You have an application which is writing the stream of events to Kafka or to Event Hub or any other place, and I have a function which is reading this event and applying it on the database. So that is event sourcing in the most simplest form. But we want to make this system much more simpler. I want to simplify this more. So I want to use event sourcing, but how I can simplify this system? If I can remove this Kafka or Event Hub and write, this application can write data directly to database, then as you can see, this is such a simple system now. One less component in your whole solution. And the data is going directly in database. Now, this kind of pattern, doing this kind of pattern is very difficult few years back because you don't have databases which can take millions and millions of records per second. But today, we have database like that, which can take this kind of throughput and still expose you the logs. Because remember, the event sourcing pattern was dependent on the log, the stream of events. So today, what if I can have a database which can take million of requests per second and still expose the logs? And that brings us to second stack of our presentation. Like we talked about design patterns, now we are getting into the technology section. And we do have a technology like that, and which is called Cosmos DB, Azure Cosmos DB. It's a fully managed, globally distributed, multi-model, multi-master database. And it's a mouthful. I will explain each and everything. What do we mean by that? So Cosmos DB is a database which is born in cloud. From the day one, from the inception, our design goal was to have great global distribution story and elastic scale out and guaranteed low latency. That was like our top priority when we started designing this database. And let me talk a little bit more about global distribution. So when I say global distribution, by that I mean that globally, Azure is in 52 data centers, which is more data centers than Amazon and Google combined. And Cosmos DB is ring zero service of Azure. So wherever Azure is, Cosmos DB is there. So you can imagine the footprint of Cosmos DB. Wherever your customers are, you can keep the data very near to them. So that's about global distribution. But most of us have come from relational databases background, and we know how difficult replication is. We have to set all this replication across the world and monitor it and manage it. And they break down sometime, and then we have to fix it. But here in Cosmos DB, to do the global replication, you have to go to a portal where there's a map of the world, and all these data centers are there, and you just go and click, 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 and that's it. First time when I saw it was completely mind-boggling. I couldn't believe that I can distribute my data by just clicking on a map of the world, and my data is distributed. And I don't have to do anything, no configuration, nothing. That's it. My data is getting distributed. And once my data is getting distributed, my application, my devs also have to do nothing to write an always-on application. By that, I mean whenever you write the data in Cosmos DB, we write in 4 copies in the same data center. So if there's a problem in one machine or there's some problem in one data center, your user will feel nothing. Your application will keep working. They will know nothing that there's anything happen in the background. And in the worst case, if the whole data center is blown away, still your user will not feel anything but maybe 100 millisecond or so latency because we will flip to another data center. And imagine again, as a dev, you don't have to do anything. It's just happening because of the Cosmos DB. You are using Cosmos DB, and you replicated the data, and it's happening for you. So that's the beauty of global distribution in Cosmos DB. Second, elastic scale-out. So we can scale out your storage and throughput automatically. So storage keep going up as your application users will keep growing. You don't have to do anything. Again, no configuration, nothing. When you're creating the collection, you just say, I want unlimited storage. That's it. It will keep growing. Keep growing, I mean, you go in terabytes and petabytes. And no question will be ever asked. Your application will never stop. It will keep working. And on the throughput side, throughput we define in RU, which is request unit. And the definition of request unit is 1 kilobyte of data coming in and out of Cosmos DB. So when you are provisioning your collection, you say, I want 100,000 RUs per second. And that's what we will provision. We'll figure it out, how much network bandwidth you need, what hardware, what CPU, all this we will calculate for you. And we will guarantee that you will have this throughput. And for this elastic scale-out, we have some customer who used to have 1 million hits per second, and for Black Friday, they went to 3 million requests per second, and the system kept working. So we do have already proven with very, very big customer, with very big businesses, depending on this elastic scale-out. And we have a guaranteed low latency. Everything, all the rate should come back within 10 milliseconds, write within 15 milliseconds. And with multi-master announcement yesterday, we'll go to single digits in both read and write. We have a very well-defined 5 consistency model, and all this is backed by very comprehensive SLA of Microsoft. If we'll not meet this SLA, which you will see it on your portal, we will return back the money. So on this platform of core capabilities of Cosmos DB, we build a multi-model database. What do we mean by multi-model? Multi-model means you can keep different kind of data in this database. You can keep key value, white column, documents, or graph, all in this one database. Like if you see our competition, you have to buy 5 different databases to do the same thing. But in Cosmos DB, you can keep all this data in one database. And to deal with these different kind of databases, we have different client libraries. Now here I want to clarify a few things, which is source of a lot of confusion from people. When I say Cassandra, MongoDB, or Gremlin, you can keep that data in Cosmos DB. By that, we don't mean that there's a Cassandra or MongoDB inside Cosmos DB. No, it's all Cosmos DB. There is no Mongo there. But we are wire compliant with Mongo and Cassandra and Gremlin. So when they speak, their tools speak to us, we understand their language. That's what we have done. So all the data is kept in our own format, which is JSON. We call it ARS, Atomic Record Sequences. All this data from different format is kept in our own format, and you can use any of the client library to talk to us. We have a SQL API, also client library. This is, again, source of confusion. When people see SQL, they wonder, is the SQL server there inside Cosmos DB? No. This is a non-relational database, schema agnostic. This is not a SQL server. There's no SQL server. So what we mean by SQL client library is you can use SQL language to query the Cosmos DB and get the data. So you can say, select star from this collection where city equal to Seattle. So that's what we mean when we say SQL API, that you can use the SQL language to query our database. And this client library is in many languages. You have it in TypeScript, JavaScript, Java, C#. So there are many options. And if you are using Mongo and Cassandra, we don't want you to learn anything new. you can keep using your application, your code, just move the data using Mongo import and Mongo export to move the data in Cosmos DB, change the connection string, and your Mongo application should keep working with Cosmos DB. So that's the ease we are trying to bring with Cosmos DB. So another important feature of Cosmos DB is change feed. And change feed is nothing but we are exposing our logs of Cosmos DB logs out through the change feed. So you can read the change feed, and you can see what is changing inside Cosmos DB. So change feed is kind of a window inside the Cosmos DB. You can look inside Cosmos DB and see what's happening. And this change feed is enabled by default. Again, you don't have to do any configuration, nothing. And you can read this change feed from any region. And all the insert and updates will show up in change feed. Delete is coming very soon. Within a month or so, you will have a delete, shows up change feed. But you can put a soft delete. So that will show up in the change feed. And then you can put a TTL, time to live on that record. And that record will be deleted after a minute or second. So that's how you can get the delete also on change feed. So with this change feed, you can enable light up multiple scenarios. Number one is you can have your Azure function listening to this change feed. And whenever the data comes in Cosmos DB, you get that data, that document as a parameter inside your Azure function. And there, it's your code running. And from there, I will say, sky is the limit, because you have what document has changed, and it's in your function, and you own completely the future of that document, and you can do anything. You can call a notification service. You can call another logic app. There's a multiple options there. Second one is stream processing. As the data is coming, again, I'm saying with million of requests per second, with that speed, with that throughput, you can have that data come in with that speed, and you can, using the change feed, you can process it. You can use Azure Stream Analytics. You can use Spark. And we have our native Spark connector written with Cosmos DB. And the beauty of our connector is, because that connector is written by us, it understands the Spark, it understands the Cosmos DB, and both of these technologies dependent on distributed data. So, and you all know the big data problem is, biggest problem is moving the data. Terabytes and terabytes of data, that's the most amount of time you spend. But if you will use Cosmos DB connector, it will push the predicates down. So if you have a document with hundreds of attributes, but you are interested in only 2 or 3 attributes in Spark, so you can say select column 1, column 2, and that's all the data will come back to you. So it helps you process your data much faster. So that's Spark, and you can use Azure Stream Analytics. And third option is you can take your data and you can archive your data to Azure Data Lake or put it in another collection. So this is what we talked about, that you can have this microservice architecture, again, enable on Cosmos DB change feed. We will talk more about it, and I'll show you how the customers are using these patterns. We talked a little bit about materialized view before, but here you can see that I'm creating a materialized view and counting the subscription. Especially when your data is coming with very, very high throughput, and you want to connect reporting to that, you can use this change log, do the calculation, put that back into another collection, and then you can connect your BI reporting on top of it. And that will help. So you are not doing any calculation at the real time. And last one, we talked about replicating the data to different kind of data stores. From here, you can take to your data mart or data lake itself. yesterday, I think Microsoft announced about Open Data Initiative, right? When we are bringing all the customer data together and giving control to the customer to have their own data. Thanks to the GDPR initiative from Europe, we start moving in that direction. And this is one way you can do that. I can read all the data coming in, and then I can move it to somewhere where I can collect all the data together. Now, when I talk about that, very, very high throughput, when millions of rows are coming in Cosmos DB, how I'm going to process it, how I will scale out. Because remember, all the solutions will not work if I don't have a scale-out story. Because the throughput is so high, you have to have a scale-out story. So here we can read change feed in multiple ways. We can use document client libraries, we can use change feed processor library, or we can use Azure functions. And when I'm using processor library, I'm taking control of a lot of things, that what data I want to read. And I can have multiple consumers reading my data, reading the change feed, and I can have them divide and decide themselves, I will read this partition, and the other consumer will read the other partition. And the beauty of this processor library is, if you have, say, 30 partition, and you just put 3 consumer, and you are using our processor library, these consumers will know about each other, and smartly they will say, let's decide and divide 10 partition for ourselves. And then if you create more consumers, say 10 more consumers, then they will say, okay, there are 10 more consumers, so let's divide this partition 3 for each consumer. So you don't have to do all that. The solution is built on the observer pattern. So when you are using the processor library, your code will be called by the processor library itself. And it has a lot of intelligence that it can divide your partitions accordingly. Like how many consumers you have, accordingly they will define themselves. And once a consumer will die, again, they will divide the partition among themselves. Next thing in our technology stack, we are going to talk about Azure functions. So what is Azure function? Very simple definition is, it's a function which is living on Azure. And the beauty of this is, you don't have to worry about all this infrastructure management, how to deploy it, write a service, and patch machines and all that. You just write your function, that's it, and you don't even worry about who is calling and how. That can be wired differently and later on. And these functions can auto-scale depending on your load. So if you have suddenly load kept on increasing, again from hundreds of hit per second to 1,000 or 10,000, these functions will spawn more and more functions will be there, initiated, and you don't have to worry about any of these things yourself, that how I can do this. And no wasted resources. Again, if your function is not getting utilized, after 5 minutes, it just sleeps, and you don't get charged. So that's the beauty of Azure function. The next one is, the other benefit is that you have all these different bindings and trigger. So all Azure services, if they're in our doc, there's a big table, like what bindings you can have with Azure function. And binding means you bind and say Azure storage with your function. And you say when any file get dropped on the storage, wake me up, and that function will get triggered. So you can have all this trigger and binding behind the scene just by configuration to enable your Azure function. And that makes your whole solution very easy and simple, because you write the solutions, those small functions, and they get activated whenever there's a trigger or there's a data comes in Cosmos DB, they will get triggered. Proxies, if you have many many functions, and you want to have just one API surface for customer, you will use proxy. CI/CD integration is there, continuous integration, continuous deployment. These tools are very well working with Azure Function, so you can use them in your production environment. Local debugging. That's, again, such a great feature. You open your laptop and write a function, and then you run it. When you're running it, it's connected to cloud. And if there's a file is dropped on Azure storage or any document is inserted in, say, Cosmos DB, you will get a breakpoint on your laptop. And you can literally breakpoint and see the value of all the variables, and you can debug from your laptop. And then if everything is working, you can deploy. So this is one thing we should have in our tool set because it simplifies a lot of your work. You can do it, you can develop it in multiple languages. All this C#, F#, Java, JavaScript, all this is available. Hosting options, I'll talk about hosting options in a minute. So mostly, Azure functions are all about being stateless. They come and go, they get triggered, they wake up when there's a work needed to be done, and then they go away. But there are situations where you'd like to have these functions have state also. And that's where the durable functions comes in picture, that you can write Azure function which will save their own state. And you have multiple dev options. You can write it in Portal also. Open the portal and write the Azure functions there. You can write it in Visual Studio. You can write it in VS Code. So there are many, many options there to write this Azure function. So here are 6 different ways you can host your function. And the first one is consumption plan. So in consumption plan, this is the simplest one. You write your function, deploy it. If it is consumed, you pay for it. If there's no consumption, you don't pay for it. It's as simple as that. But sometimes you want these functions to be always on because you have a processing to be done. You don't want function to be sleeping and then it wake up and then start processing. You want it to be on. And that's the time you will use this app service plan. Sometimes you would like to keep this app service function under your own VNet. So that option is available too. You can write this function on Azure Stack. You can run them on your own server also. And in the end, you can have these functions running on IoT Edge also. So you can write the function again, host them on cloud, or host them on IoT Edge. So you can see the breadth of this. You can go anywhere, and it's all so simple that you can debug on your laptop. When you're satisfied, you can just deploy it. Now we have seen the beauty of event notification and event-driven architecture. And once you realize that, oh, if I use events to talk to different part of my application or modules, why you will ever write something which will directly call each other? Why you will ever have a tight coupling? And we realized that, and that's why we got you the event grid. With event grid, this is a pub-sub model, like publishers and subscribers. So on the left-hand side, you can see all these publishers. They can publish all these events. And on the right-hand side, you can see the event handler. And this is, again, so simple. You go to the portal, get an event grid, and just define what are your publisher. And you don't have to keep polling. I don't know if you guys must have written these kind of apps. A few years back, it's extremely complex because you will go and poll something and figure it out what's happening. Or you will write code which will call some web service if something happens, so you can send an event to another service that, hey, something has happened. Now with this event grid, all this thing is very, very simple. And as you can see, event handler side is Azure function. So again, once you get it in Azure function, sky is the limit again. You can take that event and do whatever you want from that. So it's fully managed event routing system. It's fully managed means you don't have to worry about it's up or down and how to, you just do configuration initially, and that's it. It keeps running, and it will keep routing your events. It's a almost near real-time event delivery at scale. And it has a very broad coverage within Azure and beyond. It is truly a backbone of event-driven computing. Now, what are the benefits? So again, here you are just focusing on innovation and pay per event. And you don't have to worry about all other things around it, about deployment and machines and patching and all those things. You ensure reliability, performance for your app. And obviously, you can unlock a lot of new scenarios for your app once you know this pub-sub model. Here are the subscribers, and here are the publishers. And you can connect any two different pieces together. This is the glue of event-driven applications. You can use this glue to stitch a very humongous, complex, big application. And you manage all the events in one place. Obviously, we have multiple SDKs in all different languages: Python, Java, Node.js, Ruby, .NET, and you can use any of the SDKs to build your application. You ensure reliability and performance in your app. It's highly available. It's 4.9. And as you can see, it's 10 million events per second per region. So even if you are one of the biggest applications, like maybe Skype, you can still be happy with this kind of performance because it's 10 million events per second per region. So you can have multiple regions. So whatever scale you want to bring it on. And it's very, very highly reliable because even if anything happens, the system will automatically keep retrying. Now, we did two things so far. We looked at some of the design patterns and some of the technology. So now, let's go back to our design pattern and see what we can change with this newfound knowledge which we learn about Cosmos DB, Azure Function, and Event Grid. Remember, we were at event sourcing pattern where we were writing all the events as a log, in a log. But now we know that I have a Cosmos DB which can take all this throughput directly in the database, and I don't have to have this one extra component in my design, Kafka or Event Hub, which will take, then I will read again. So this is a durable store again, right? And this is globally distributed also. So you can write the event here in US and maybe read from Europe or read from Asia. So that's the beauty of this Cosmos DB. Now, I can write the event directly in Cosmos DB, and then using the change feed, I can write any other function which can get triggered. So imagine the possibilities with this, that you can have a simple system which is directly writing the events in the Cosmos DB, and then you can light up your microservice architecture, and with less components. So this is one of the things, this is one of the takeaways if you get from this session, that how you can simplify your event-driven application. This is the one, that you don't need another extra component, write directly in Cosmos DB, use change feed, and light up your microservice architecture. So far, we kept talking about theory, and I'm just giving you some numbers and talking about all these features and all, but you may be wondering, is it really true? All this you are talking about, millions of events and all, but is somebody using it? Is there people who have built application all these things? And here is one of the use case we have. This is Walmart, jet.com. You can go to our doc site and search Cosmos DB and jet.com. You will get a very, very detailed case study how jet.com is using Cosmos DB and change feed to enable their event-driven application. So they used to have Kafka cluster, and whenever you are shopping on their website, all the data is going in the Kafka cluster, and that's how they had this event sourcing pattern. And one day, their whole Kafka cluster went down. And it took them a couple of hours, 3 or 4 hours, to bring it up. And you can imagine 3, 4 hours, if something is down, what will happen to the business? Or, Xbox. The game is going on. And imagine if the system goes down for some time. With Cosmos DB, it's durable state, and it's replicated 4 times. So there's no way you can take down Cosmos DB. We are giving you 5 nines availability, read and write both. So this is much better than having any other event sourcing. So that's what jet.com is using. And as I said, you can go and talk about or read about it in much more detail. They talk about how was their design was before, and once they come to know about Cosmos DB, what all things they have changed, and how they are using it. The next one is Skype. As you know, Skype is as big an application as big as it can get. And they moved from a relational database to Cosmos DB. And they wanted to enable their CQRS pattern, and that's what they are using Cosmos DB for that. Using the change feed, they enable their microservice architecture, and there will be a case study we will be publishing very soon, so you will get more detail on that, how it is used. This 911 scenario, this slide I made about an year back when I joined the team, thinking, how we can use Cosmos DB and change feed. Long back, I worked for Kuwait police. And that time, we had this kind of a system. And that system was costed at maybe $10 to $20 million. A lot of companies were involved there. Nokia was involved, and a couple of American companies. We changed the Nokia phone to do all this thing, to send the alert from the car. And so I wanted to build something like that if there's an IoT devices in the police car or in any other car, you can get this microservice architecture can light up, reading the change feed, and all the services can be dispatched. So that was just my imagination. I was thinking I should do that. But just a month back, I come to know there's a city in US, 911, is implemented exactly the same thing. I did not get permission to take their name. Otherwise, I would have told you. But there are people who implemented exactly the same thing. And I am hoping to bring the case study. It's beautiful to see how they have implemented an event-driven architecture using Cosmos DB and change feed. So when the police car is driving, they can have your car number plate can be read automatically, send back, all this microservices architecture get light up, and they will find out if you belong to some gang by the cop without him doing anything. He's just driving behind you. So this is the beauty of event-driven architecture. So a quick recap. We talked about a couple of design patterns. We talked about tools and technology, and then we talked about solution. Thank you very much for your time. Really appreciate your presence here. Thanks.